How you doing? My name is Sscon and I work for AC Beyond. Where we left off last time was we're going to wire up the low pressure. We already did the main voltage. Everything's already main, compressor, and the evaporator. We have compressor, the evaporator here. Okay. On the legend, we need a transformer also over here. Anyway, so now beyond this, now we're going to check the control voltage. Okay. Now, as far as remember, the voltage for the cooling will be with switches that I put here before, right? So, now, remember though, from the thermostat Y1, which is yellow, we'll go here, we jump to a low pressure switch, okay? Now, it's going to look something like this. Okay, something like this. Okay, Y1, we're going to go to the low pressure switch here. Okay, now the other side of the low pressure switch is going to go wired in series with the head pressure switch. Okay, which will be right here. Okay, so we can say that this wire here is going to be with a wire not connected here, and this here, and the other side of the head pressure switch, which is right here, okay, right here goes to one side of the coil, okay, because the other one's coming from the low pressure switch. So it has a low pressure switch here, head pressure switch here. This was going to go all the way to the, well, the coil's on the bottom, but today we leave it right here, okay? Okay, this is the coil. This is CC, compressor contactor coil, okay? Now, from the low pressure, from the compressor contactor coil goes to common. If I remember, this is common wire, which is here too. So from the common wire, and it's right here, right? So we're going to run the cable from all the way here to common, okay? Now this is your common wire, okay? All of this, don't confuse them with this. This is your main voltage, and oh, you know what? Let's fix this here. It looks a little messy. So let's put it here like this, and let's put it here like that, okay? So now we know that from the head pressure switch goes to the coil, to the common side of the transformer. So that's where already wired up, okay? Now we're going to wire up the green wire, which is your G, okay? If you notice here, okay, this is your G. This is your terminal strip from G. It has a coil and common, okay? So with the G, we're going to use a different color, okay? So we'll get confused now. So with the G wire, we're going to have G, going to have here, connect to here, but put it right here, okay? So right here your G. So this is your coil, okay? Now the other side of the coil, that we know that this goes to common, we'll pick up the common and we'll go here, okay? Anyway, so as you notice, G, the wire, the terminal strip from G goes to one side of the coil, okay, and then the other side of the coil goes to common, which is right here. G, one side of the coil, and the other side of the coil goes to common. This is how it's going to look on the wire and the actual air conditioner, well, except for the images. But this is going to be your contactors. Power comes in and stays here, okay? Now the way it works is, when you have it on fan is going to come on. Just fan on, that means fan is going to be running all the time. If you put the fan on auto, on your ICM thermostat, hold on, let's see if this works. Okay, on the ICM thermostat, if you put it on fan, that means only the fan will come on. So the fan will bring 24 volts to the coil. Contactor pulls in. Okay, the main power stays here. Remember, this has two voltages. It has a main voltage and the control voltage. Okay, so the main voltage is here, and the voltage is still waiting over here, and it goes to the fan. Okay, so what happens is when you call for a fan to come on, fan energizes the coil, the evaporator coil. The contactor pulls in, fan comes on. Okay, that's only when you have a fan on. If you have a fan on auto, the way it's going to work is fan is going to do the same procedure, but at the same time, when you need cooling, you have Y1. Y1 comes here, goes through the little switch, which will be will be here. The little switch now goes, if it's closed, if its pressure builds up, it's going to be closed. Then from here, it's going to go to your head pressure switch, which is also closed, and then you energize the coil, and then we'll bring your compressor contactor coil, will pull in, and then your compressor comes on. Now let's suppose if you do have a problem, what will you do? Okay, now we're going to use the same procedure from before. Okay, we're going to check. First of all, let's just say that here, this is R and this is your common. R and common, same thing, but I'm going to put it in here. Okay, first we're going to check if we have 24 volts. Okay, that's first you're going to check. If you have 24 volts, good. If you don't have 24 volts, that means you have to check your transformer. Okay, and then you check from here and here. Okay, check between here and there. Okay, and also remember, if you get 24 volts here, but you don't get 24 volts here, the terminal strip, remember you have a fuse over here. You have to check your fuse. Okay, you can remove the fuse, kill the power, remove the fuse, put it on ohms. You should get a reading of 0. Okay, that means that there's no resistance, the voltage goes through. Okay, if it goes on OL, it means open line, that means that fuse is no good. I mean, we're going to talk about that later on also. But anyway, so let's suppose that you get 24 volts here and you get 24 volts here. So you have 24 volts, which is fine. Okay, now your next procedure, you're going to be your Y1. If you check between Y1 and R, and you get 24 volts. Okay, now if you remember what I was saying before, over here is only a switch. Okay, if you get 24 volts here, this is open, meaning that somewhere from the thermostat to the terminal thread is open. So if you get 24 volts, the problem is outside. Okay, if you do not get any 24 volts and you get 0, that means your problem is inside. Okay, now that's another thing. If you have 24 volts outside, you know it could be a thermostat. See, right now we only have thermostat. That's the only thing we have right now. So that means that somewhere in the thermostat, maybe it's not programmed, maybe it was off, anything, but you have to check. But remember, same thing. If you have a thermostat and it's lit up, it doesn't mean it has power, because it has batteries. And if you have the other ICM thermostat that needs power, then you have no display, then you know probably, yeah, you know what, it's the power. But you have to remember which type of ICM thermostat you are using. So, another thing also, that let's suppose that that's the problem, okay? And let's say that you get 0, okay? So the problem, you know, if the problem is inside, we can check a couple of things, okay? Remember the head pressure switch? Where's the head pressure switch? The head pressure switch. Let's say the pressure went up, okay? This unit is your water cool system. There's no pressure, it opens up. Now if you remember, if you put your meter on it and you get 24 volts, same thing, that means it's open. Okay, like we said before, we're going to talk about more about the hopscotch. Okay, but this is it for now. So don't forget to subscribe to Instagram or on Facebook or on Twitter. Look me up on LinkedIn under Oscar Moran, and on the other one should be under AC Beyond. Okay, thank you and goodbye.